Hello everyone. Today we'll be looking at systems of linear equations and solving them through the elimination method. So our objectives are going to be to first describe the method of elimination and second, solve a system using elimination as an example. So the method of elimination can be broken into a few steps. Step 1, you'll need to write both equations in standard form, ax plus by equals c. Quite often this is already done for you. Step 2, transform the equations as needed so that the coefficients of one pair of variable terms are opposites. Step 3, add the new equations to eliminate a variable. Since you transform the equations in step 2 so that for one of the variables at least the coefficients are equal but opposite, one of that variable should eliminate when you add straight down. Step 4, solve the equation from step 3 for the remaining variable. Step 5, now that you have a value for one of the variables, you can substitute the result from step 4 into either of the original equations and solve for the other variable. At this stage, you should have values for both x and y, to which then, step 6, you will check the solution in both of the original equations. Let's see how this method is implemented. So here's an example. Let's solve the system 4x plus 3y equals 10 and 2x plus y equals 5. So step 1, let's write both equations in standard form, ax plus by equals c. That's actually already done for us, so check. Quite often that's the case. Step 2, let's transform the equations as needed so that the coefficients of one pair of variable terms are equal but opposite of another. So I'm going to try and eliminate the y. So I will take equation 2 and I will multiply both sides of equation 2 by -3. That gives me the pair of equations 4x plus 3y equals 10 and -6x minus 3y equals -15. As you can see, the coefficients on the y are equal but opposite, 3y and -3y respectively. So step 3 is going to be to add the new equations to eliminate a variable. So there are the two equations we got from step 2. And if I just add these two straight down, you can see that the y's eliminate, and I'm left with -2x equals -5. And then in step 4, I can easily solve the equation from step 3 for the remaining variable x, and get that x is just positive 5/2. So now, for step 5, I can substitute the value of x equaling positive 5/2, the result I got from step 4, into either of the original equations and solve for the other variable. It looks like I'm going to choose equation 2 simply because after I plug in x to be 5/2, I can see that this is going to be pretty easy to solve for y. The 2's cancel. I get 5 plus y equals 5, so the only number that I can add to 5 to get 5 must be 0, so y is 0. And that yielded for me the ordered pair x comma y equals 5/2, 0. Now it's going to be time, as always, to step 6, check that the solution in both of the original equations. So as a reminder, my solution I had was x comma y is equal to 5/2, 0. So when I check that in the first equation, so 4 times 5 halves plus 3 times 0, 0, and I see, does that equal 10? Of course, the y term zeroes out, and if I look at 4 times 5 halves, that reduces to 2 times 5, and 2 times 5 does equal 10. And then if I check in the second equation, and I plug in 5 halves in for x, and 0 for y, and I ask myself, does that equal 5? I can see that the 2's here cancel out, and I get 5 plus 0, and yes, 5 plus 0 does equal 5. So that the solution we got, 5 halves comma 0, is actually the solution to the system. And that concludes our video for systems of linear equations, solving them through the elimination method, where we first describe the method of elimination, and then second, solved a system using the method of eliminations. Hope you have a wonderful rest of your day.